In this video, we are going to start example 7.8.2. So let x and y have joint probability density function given here, and we're asked to first find the joint cumulative distribution function, and then verify the properties from proposition 7.8.1 that we saw in the last video. So we're going to start with the properties in the reverse order, and so the first one we are going to do is property 4, which actually tells us how to find the joint CDF and then how to double check our answer. This is actually a property of the fundamental theorem of calculus, not really of probability, but we will go ahead and check it anyway. So we have here f of xy, and that is going to be, by definition, the integral from minus infinity to x, the integral from minus infinity to y of dummy variables, f of u v dv du, which means that we need to integrate from 1 to x and then integrate from 1 to y of the density with dummy variables put in, so u squared v cubed dv du. And so we need an antiderivative with respect to v, which is going to be 1 over, so we've got a power rule, minus 2v squared, and I brought out the 2u squared, and this is going to run from 1 to y with the du on the outside, so we can cancel out those 2's, which is going to give us the integral from 1 to x of 1 over u squared, and we get 1 over minus y squared minus minus, so plus 1 du. Now this is a constant with respect to the second integral, so we can bring that out of the front and write it in a little more naturally of 1 minus 1 over y squared times the integral from 1 to x of 1 over u squared du. Now we need an antiderivative for 1 over u squared, and so that is just going to be, well, we'll keep the constant in the front. Antiderivative is minus 1 over u, which now needs to run from 1 to x. And so for the joint CDF, we get the product 1 minus 1 over y squared times 1 minus 1 over x. Now, for property 4, we need to verify that if we take the mixed partial of this, that we'll get back to f of xy, and that's pretty easy to see. So let's just do that real quick. So f of xy should be the mixed partial del squared f del x del y, and which gives us del by del x of, and we'll take the derivative here with respect to y. So this part is a constant. This is, again, the reverse of the power rule. It really is just the reverse of what we did up here. And so we are going to get minus 2 over, oh no, the minuses will cancel, right? That's fortunate. So we'll get 2 over y cubed times 1 minus 1 over x, and we have to take the derivative with respect to x. So we get 2 over y cubed times 1 over x squared, which is 2 over x squared y cubed, which is exactly the density. So that's just the fundamental theorem applied twice. So that verifies. Now, we're going to look at property 3 as well, and property 3 was about the marginal CDF. So we'll only do one of them. We'll do f sub x of x, and we're going to find it by the definition and then compare to the property here that if we take the limit as y goes to infinity of the joint function that we just found, we should get the same answer. So to find the marginal, right, we need f sub x of x. This is going to be the integral of the marginal density, the integral from minus infinity to x of f sub x of x, which I need to put in as a t. I need a dummy variable here, dt, which means I need to find this marginal first. And so that marginal is, so f sub x of x is what we need to integrate the density. We need to integrate out the y from the joint density. So we're integrating, So from minus infinity to infinity of f of x y dy, that's the definition. And so that means we need to integrate from 1 to infinity 2 over x squared y cubed dy, which means that we need, so 2 over x squared is a constant times the limit as t goes to infinity. We need an antiderivative of 1 over y cubed, which will run from 1 to t, and that gives us, it's the same antiderivative as before, only with y, so 1 over minus 2y squared. That 2 will cancel down with this 2, and we end up by getting 1 over x squared times, I forgot the limit, so let's write that in. So 1 over x squared times the limit as t goes to infinity of 1 over minus t squared minus minus is plus 1. And then as t goes to infinity, this term goes to 0. And so our marginal function is 1 over x squared. So this is what we need to integrate here. So let's go and plug that in, which means that we need to integrate over the correct support, which is going to be from 1 to x of the marginal with a dummy variable t. So 1 over t squared dt, which means we need the antiderivative minus 1 over t from 1 to x, which when we plug in, we're going to have, so minus 1 over x minus minus plus 1, or 1 minus 1 over x. There is our marginal CDF. Now, the properties of the joint CDF say that we can plug in infinity, which really means that we're going to take the limit as y goes to infinity of the joint CDF. So the limit as y goes to infinity of this joint CDF, which was up here. And so that is going to be 1 minus y squared times 1 minus 1 over x. Of course, this term goes to 0 as y goes to infinity, so we're going to have 1 minus 1 over x, which indeed is the marginal CDF that we found from first principle. So that property is verified as well. In the next video, we'll go on and verify the two remaining properties, property 2 and property 1. See you then.